Hello dear students, here I am Dr. Amjad Ali. In this video we are going to learn correlation coefficient for group data. As previously we have covered our simple correlation methodology when we have a one variable or one frequency table. So if a simple frequency table, the data is arranged with respect to one variable only, this is called the simple correlation. But if the data arrangement is made according to two variables simultaneously, let's say we have m columns and k rows, the frequency table that's obtained is called the correlation table, but we call it a bivariate frequency table. And here the number of observation falling in the ith or jth cell is called the ith and jth frequency, and it is denoted by Fij. And the correlation coefficient, if it exists, keep it in mind that if correlation exists, can be calculated from such two-ways frequency table by using the class midpoints as the value of observation. The formula for the correlation become as compared to simple correlation. This formulation is totally different from the simple correlation that we have. R is equal to summation Fij, summation Fij into xi yi minus 1 over n into summation Fj, summation j into summation j multiplied by summation multiplied by y, and the whole summation x and summation y is multiplied with frequency and then take the under root. This is the formula for the group data correlation matrix. Let's see the interpretation of this formula that we have. Here we have summation Fij ranges from j is equal to 1 ranges to m, and the frequency, this is known as the frequency of y values. And we have summation j, we have Fj is equal to summation Fij ranges from j is equal to 1 to approaches k, and here we have the frequency of x values, and n is the number of total frequency. Okay, let's see the empirical examples. Students, keep it in mind that the empirical example of group data correlation matrix is need your careful understanding and observation at the same time, because there are a lot of calculation in a same table. So let's see, we have a y variable and we have x variable, and here we have classes for the x variable, and we have the classes for the x variable. Okay, let's see, we have some observation or frequency for the x variable, and here we have the frequencies, and we have the frequencies for the y variable at the same time. And the total of frequencies of x variable and y variable, see the total sum of both variables, the total frequency is 100, and the row this row shows the frequency of this row, and this frequency shows the frequency of total the frequency of this row and this row, and here you can see the total frequency of this column. So the sum of these and sum of these equal to 100. So this is the main quality of group data correlation. Okay, let's see, we have to introduce two new variables. That we have u and v are given by the relation. That we have u is equal to x minus 64.5 divided by 10, and v is equal to y minus 74.5 divided by 100. So keep it in mind that here the calculation is going on. So when you have gone through the arithmetic mean or standard deviation, when you have a x variable, then you have to convert the classes into midpoints, and for the y variable we have to convert the classes into midpoints. So let's start our calculation. So you have to find the correlation here. So we have a midpoint for the x. So you know the how can we find the midpoint? You have to sum this and divide it by 2. You have to sum this, both of this, 50 plus 59 and divided by 2. Like that you have to sum 90 plus 99 divided by 2, and you get the midpoint of variable x, variable y and variable x. Okay, let's start. We get the midpoint of x and we get the midpoint of y. Okay, now these midpoints, midpoint of x and midpoint of y. So let's start. The midpoint of x can be put in this formula and we get u. After putting midpoint of x alternatively in this formula, we get the value of uj. This is called the uj. And after putting the value of yi in this formula, we get vi. So this is called the vi. Okay, here is a new calculation, so see it carefully. Let's see, we have a frequency which is given 244, which is given in our question at the same time. So from where this 4, 16 and 24 we get? So see here, if you multiply this and this is here is nothing given, so that's why we don't put anything. Multiply this and this, here is nothing, so that's why we put nothing. Multiply this, here is nothing, so we don't put anything. So let's see, here we have here 2 multiply by 2 and then multiply by 1, so we got 4. Multiply 2 by 4 and then multiply by 2, so multiply 2, 4, 8 and then 2, 16. Multiply 2 with 4 and then 3, so it's got 8 and then multiply by 3, we got 24. Okay, now see it carefully. We multiply this by this and then this, so we have a here 0, so all the multiplication become 0. So multiply 1 by 4 and then 1, we get 4, and then 1 multiply by 6 and then 2, we get 12, and then 1 multiply by 5 and then 3, we get 15. Okay, next we have 0 multiply with the given frequencies, and all the upper side becomes 0, because if you multiply 0 with these numbers, either these numbers, it becomes 0. So that's why this part of frequency is become 0. Okay, let's see, we have here minus 1. Minus 1 multiply by 1 and then minus 2, we get 2. Minus minus plus, minus 1 multiplied by 4 and then minus 1, so we get 4. Minus 1 multiplied by 9 and then 0, we get 0. Minus 1 multiplied by 5 and then 1, we get minus 5. Minus 1 multiplied by 2 and then 2, we get minus 4. So here we have nothing in the question, so that's why it is empty. Okay, here we have minus 2 multiplied by 3 and then 2, so here minus 3, 6, minus 6 multiply minus 2, it is 12. So here minus 2, 6 multiply minus 1, so we got it 12. Minus 2 multiply by 6, 12, and 12 multiply by 0, we get 0. Minus multiply by 2 and then multiply by 1, we get it minus 4. Okay, the last one, 3 multiply by 3 and then minus 2, we get it plus 18. Minus minus will be cancelled. 3 multiplied by 5, we get 15, and then minus 1, we get plus 15. 3 multiplied by 4 and then 0, we get it 0. Okay, this is the simple multiplication of the frequencies of V and U and frequency of X, J and YJ. Okay, let's clear these frequencies here. We have the frequency, so you have to add these previous frequency. This is called the Fi. So 2, 4, 4, 10, 1, 4, 6, 5, 16, 5, 10, 8, 1, 24, 1, 4, 9, 5, 2, 21, 3, 6, 6, 2, 17, 3, 5, 4, 12, and this is sum. Its sum is equal to 100. And then we have Fi Vi. So you have to multiply Fi by Vi. So this is the Vi. So you have to multiply 2 by 10, we get it 20. 1 multiplied by 16, we get it 16. 0 multiplied by 24, we get 0. Minus 1 multiplied by 21, we get it minus 1. minus 2 multiplied by 17, we get it minus 13. Minus 3 multiplied by 12, we get it minus 16. And sum of Fi Vi is equal to minus 15. Now we have a Fi Vi square. So take the square of this series and then multiply by this series. So we get it 40, 60, 16, 0, 21, 60, 1, 0, 8 and 2, 5, 3. So take the square of this series and then multiply by this and we get Fiv square. Okay, let's have a last one, that Fij Uj Vi. Okay, this is the sum of Fij Uj and Vi. So 4, 16 and 24, we got it 44. Okay, next we have 4, 12, 15 and 0, and we got it 31. 0, 0, we get it 0. 2, 4, 0, minus 5, minus 4, we get it minus 3. 12, 12, 0, minus 4, we get 20. And 18, 15, 0, we get 33. And the sum of Fij Uj Vi is 125. Okay, here we find Fi. Now we have to find Fj. So here is the Fj. You have to add 1, 3, 3, 7, 4, 6, 5 without bracket. I am adding without bracket because Fi and Fj are the previous frequencies of Yi and Xj. So that's why we are adding all those frequencies without brackets. So sum of Fi is 100 and Fj is also is equal to 100. Now we have to find Fj Ui, Fj Uj and Fj Uj square and Fj. So this is the same, last one is the same. So let's start. So see Fj Uj. So you have to add you have to multiply minus 2 with 7, you get it minus 14. Minus 1 multiplied by 15, you get minus 15. 0 multiplied by 25, you get 0. 1 multiplied by 23, you get 23. 2 multiplied by 20, you get 40. And 3 multiplied by 10, you get 30. And now you have to calculate Fj Uj square. So and the sum of sorry, I forget to tell you that the sum of fi uj is equal to 64, and now you have to take the square of this series because this is uj series, and then multiply by fj series, and you get 28, 15, 23, 80, 90, and the sum of this series is 236. And now you have to multiply fi Fij, Fij, Uj and Vi, and now you have to sum of the brackets 2, 12, 18. It is equal to 32. 4, 12, 15 bracket. I am adding only bracket values. So 31, 0, 0, 0. So it is 0, 4, 4, 0 minus 5 minus 4 is equal to minus 1. So to multiply by 16, 12, 0 minus 4 we get it 24, and 24, 15, 0 we get it 39, and sum of this series is equal to 125. So keep it in mind that these values are more important for us because these are the summation values which we have to use for the final analysis. So I hope you all understand how can we calculate these cumbersome values in this table. So by using these values we find the correlation of group data. Okay, the numbers in the corner, these are the corner values of the each cell represents the product Fij, Uj, Vi, where Fij is the cell frequency. So again I put this table for the simplification because you have to use the corner values for getting the correlation of group data. So this is the formula for the correlation of group data. So we have a very strong understanding that if you are finding correlation of x, y or v, u or uv is same representation. So put these values into this formula and we get this. Now see, here we have n summation fuv is equal to 100, number of observation here is 100, and summation uv is equal to 125. So see, here is 125 and this is the frequency, or you can call it a number of observation n. So this is equal to 100. So by putting these values and after the solution of these values we got the group data correlation value is equal to 0.77. Okay, let's see the interpretation of group data frequency distribution group data correlation matrix. Okay, here we have the correlation value 0.0, which explain that the 77% variation in y is accounted by x, or you can call it 77% variation in x is accounted by y, and this is a moderate degree of relationship between x and y, and this is a positive correlation between x and y. So keep it in mind that through the simple correlation methodology we also learn that there is no concept of independent and dependent variables in correlation results. Here we have two more situations and we want to learn that what is the sign of the group data correlation. And here we have one first condition, that correlation between x and y shows that the correlation between alpha, or you can call it ax, and by is minus or negative, plus or minus, or plus or negative according according as A and B have the same or different signs. So if A and B have a different sign, then what is the sign of the correlation of the variable? And the second, we have to find the correlation between X and Y connected by you can call it as a straight line, that AX plus BY plus C is equal to 0. So let's start the solution of these two conditions and find that what is the expected sign of group data correlation. So let we have a situation that we U is equal to AX, and so the mean of U is equal to U bar is equal to AX bar, and we have a V is equal to BY, and the mean of V bar is equal to BY bar. Okay, now we have a situation that if we subtract this from this, and we get U minus U bar is equal to A into X minus X bar. We subtract this from this, and like that we have to subtract this from this, and we get V minus V bar is equal to B into Y minus Y bar. Okay, we have a simple correlation formula here, summation U minus U bar into V minus V bar and divided by summation U minus U bar whole square summation V minus V bar whole square. Okay, let's put the value of U minus U bar in place of this and V minus V bar in place of this, and we get this. Okay, see here we have a summation A and B as a common, you can call it a constant, so that's why we are not putting in front of summation, so that's why A and B, and we put U and U minus U bar value is there, and V minus V bar value is there, so we get it there. And after solving this, we get AB and A square and B square, because if you remove the under root of this part and this part, and after removing the under root, then the square is vanished, and X minus X bar will be cancelled out with this, and Y minus Y bar will be cancelled out with this, and we get A into AB divided by A square, B square, and RXY. This is the correlation. And see, if you remove the square of this, and then under root will be vanished, and A and B will be cancelled out, then the answer of this division will be more important, because this will decide the sign of the group data here. Okay, let's see here, if both have the same sign, A and B have the same sign, then the correlation answer will be in a positive. And if A and B have a different sign, then the outcome of the correlation will be negative. So keep it in mind that if both have the same sign, then the correlation outcome consider positive, and if they have a different sign, A and B have a different sign, then correlation outcome will be in a negative sign. Okay, now we have the second condition, find the correlation matrix, correlation between X and Y connected by AX plus BY plus C is equal to 0. So we have summation A summation X plus B summation Y plus N C is equal to 0. Here we have where in N is the number of pairs Xi and Xj. So this is more important. Okay, by dividing this equation by N, we get, by dividing N, so you know that sum of value divided by their number is called mean value, so that's why we get X bar plus B X bar, and N by dividing this equation by N, and N must be cancelled out, so C is equal to 0. So we get A X bar plus B X bar plus C is equal to 0. Okay, Here we have x bar, y bar being the means of x and y set of the observation, subtracting to get. Now we have to subtract x simple value from the mean, so we get x minus x bar plus b into y minus y bar, and from here we have to get the value of y minus y bar, so this part will be converted to the other side of the equal, so that's why it become negative. So b is divided, we only want to get the minus y minus y bar, so that's why b will be divided on the other side of the equal. So we have the correlation formula, this, so this is the correlation formula, and now we have to put the values of y minus y bar in place of this and this, and we get this formula. And after the cancellation, so see, y minus y bar is equal to this value, so we put it y minus y bar here and y minus y bar into square root as well. After the cancellation we get minus a divided by a, and denominator is a square divided by b square under root. So here is more important, what is the sign of the correlation. So if a and b have a different sign, then the same sign, sorry, if a and b have the same sign, then the correlation outcome, the final correlation outcome of the group data will be negative, must be negative. And if a and b have a different sign, then in this case the group data correlation will be positive. So keep it in mind that in under this situation, if both have a same sign, then correlation answer must be negative, and if they have different sign, then correlation of group data is positive, must be positive. This is the rule for both condition A and B we have covered here. Okay, this is the formulation and empirical example for the group data correlation. So see you with another video. Okay, ciao.